In this equation, there is a y on both sides of the equation, and we need to get the y's together. Then we have numbers without y's. So our like terms, our y's, need to be combined, and our unlike. But we still have to think of this as a teeter-totter and keeping it balanced. So if I do something to the left side of this equation, I have to do it to the right side. So I'm going to start by looking at my y's. So I have a 6y here on this side of the balance and a 2y here on this side of the balance. And I don't want my number to end up negative. So the most y's that I can get rid of on both sides are 2. So I'm going to take away 2 y's on both sides. That'll make these guys go away. And if I take 2 y's away from this side, I'm left with 4y. So I have 4y minus 7 equals 9. Now, to get my minus 7 and my 9 together, I don't want to end up having to go negative. So I don't want to have to take away 9 from each side because 7's not big enough for that. So remember how we undo the operations? If this is the subtract, then I want to add. So I'm going to add 7 to this side, because if I was behind by 7, like 7 in the hole, and I come up 7, that'll put me at 0 so that those guys go away. And so I just have 4y left over here. But to keep it balanced, I have to add 7 to this side too. So that'll give me 16. Now that I have 4y equals 16, this is like the ones we solved before, where this means 4 times y is 16, so 4 times what is 16? Well, to undo multiplication, we divide. 4 divided by 4 is 1y, and 16 divided by 4 is 4. So if y is 4, then both sides of this equation would be the same. Let's just try that. 6 times 4 is 24, and 24 minus 7 is 17. On this side, 2 times 4 is 8, and 8 plus 9 is 17. So 4 does make the equation true. Another method would have been trial and error. If I try making y equal 1, then 6 times 1 over here would have been 6, and 6 minus 7 would have given me negative 1. And if I took 1 over here, 2 times 1 was 2, plus 9 would give me 11. Negative 1 and 11 are not equal, so y equals 1 doesn't work. I could try y equals 2. So 6 times 2 is 12. 12 minus 7 is 5. On the other side, I would have 2 times 2, which is 4. 4 plus 9 is 13. Well, that didn't make them equal. And I'd have to keep going and trying until I found one that worked. This can get kind of tedious, which is why it's nice to have a way to solve it like the previous screen. Let's try this one with trial and error first. So I want to find what value of p will make both sides balanced. So let's try p equals 2. That means 3 times 2 is 6 plus 4 gives me 10 on this side. On the other side, 5 times 2 is 10, minus 6 is 4. Those aren't equal. Let's go up by 2's this time. Let's try p equals 4. So 3 times 4 is 12, plus 4 is 16. On the other side, 5 times 4 is 20, minus 6 is 14. I'm getting closer. Let's try p equals 5. So 3 times 5 is 15, plus 4 is 19. And over here, 5 times 5 is 25, minus 6 is also 19. So p equals 5 is my solution. On the next screen, let's solve this same equation in the not trial and error way by actually undoing each operation. So same equation, but this method requires us to get like terms together. So I've got 3p on this side and 5p on this side. That means I can take away 3 of them from each side, and that'll make nothing over here. I'll have my 4 left, and then 5 minus 3, I have to do it to both sides, keep it equal, gives me 2p minus 6. Next, I've got the p's together. Now I've got to get the plain numbers without any letters together, and I don't want to deal with negatives, so I don't want to subtract 4 here, so I want to undo this subtraction. I want to add 6 to both sides because my positive and negative 6 put me even, put me at 0. 4 plus 6 on this side is 10, so 10 equals 2p. This is 2 times p, so I need to divide by 2 to get 1p, and dividing this side by 2 gives me 5. So by undoing each operation, by getting my like terms together, and then undoing operations, I get to the same result without guessing. Pause the video and try this one by getting like terms together. If you can't do it that way, you can do trial and error, but practice the like terms first. Okay, I have 8q and 5q, so I'm going to take away 5 from each side, 5 q's, that is. So these are gone. I have 3 q's left over here, minus 7 equals 11. So to get q all by itself, I've got to add 7, so I get 0 here. So I add 7 to this side. So 3q equals 18. This is 3 times q, so now I divide by 3. So this makes 1q equals 6. Pause the video and try this last one to see if you are getting good at it. Start by looking at my m's. I have 3 maximum on both sides, so we'll take away 3 m's to make those disappear. I'm left with 9. Take away 3 on this side. That gives me 2m minus 11 left here. This time my m is over here, so I want to get rid of this 11 that's with it. So the opposite of subtracting is adding 11. So I'm going to add 11 to both sides. These will disappear. I'll have 2m left over here, and I'll have 20 over here. Again, my m is over here, so 2 times what equals 20. This is multiplying. So to undo, I'm going to divide to get my 1m. Divide by 2. 1m is going to be worth 10.